The sport of ice hockey has evolved over the last 100 years from changes in the rules and the equipment used in order to make the game fun and safe. This sport consists of several different pieces of equipment: the stick, the skate, the puck, and of course an ice surface. Then there are the shin pads, hockey pants, shoulder pads, elbow pads, hockey gloves, helmet, a mouth guard, and a neck guard, all of which are used to protect a player from possible injury. The object of the game is to score as many goals as possible and limit the amount of goals scored against. There are a multitude of rules that make up the sport of hockey, for example, icing, offsides, and various penalties. The speed, skill, and complexity makes this an enjoyable game to play and quite the spectator experience. There are several physics-related concepts illustrated in the fundamentals of hockey. When a player skates, the skate exerts a force on the ice. As a result, the ice exerts the same force but in the opposite direction, exemplifying Newton's third law, allowing the player to move. Newton's second law states that the net force is equal to the mass times acceleration. Therefore, the more force the player's skate exerts on the ice, the faster the player will accelerate. An ice surface has a relatively low coefficient of friction, which allows a player to maintain its velocity without any additional force. This can be problematic, as Newton's first law of how an object will stay in motion unless an equal unbalanced force is present. In hockey, there are boards surrounding the ice surface, so a player with a velocity will continue to move until they hit the boards, which can be dangerous. Or there is the option of stopping. When a player rotates their skates to the point where the skate is perpendicular to the direction of movement, they create a lot of resistance as the blades dig into the ice, which enables a player in full flight to stop on a dime. A player can accelerate quickly from rest when the stride length is kept short. This allows for each push to provide an optimal amount of force more frequently. Additionally, the legs moving have a relative velocity to how fast the actual player is moving and the ice itself. This explains how accelerating with initial velocity requires more work, as the velocity of the legs have to first match the velocity of the player with respect to the ice. When a player has reached their maximum velocity, longer strides are essential as they help maintain a high velocity and increase efficiency. Shooting a puck requires strength and technique. The more force applied means a greater impulse on the puck, allowing it to accelerate more. Good form enables the shooter to utilize all forms of energy. When observing a slap shot, the stick has kinetic energy in the preliminary movement. The backswing gives the stick gravitational potential energy. Chemical energy of the muscles converts the mechanical energy of the stick as it gains angular velocity. When the stick makes contact with the ice, elastic potential energy is being stored in the stick. In the follow-through, the elastic energy is released to form more kinetic energy, thus maximizing the amount of velocity in the puck. The same idea of energy being stored in the stick is used in a wrist shot. It is evident that the stick bends as force is applied to the stick and then is released in the follow. Hits in hockey are high-speed collisions resulting in rapid acceleration, which can be harmful to the human body. Strength and ability to throw hits is important, but from a physics standpoint, having a greater mass gives that player an advantage, as momentum is conserved. Alex Ovechkin of the Washington Capitals attempts to hit Zdeno Chara of the Boston Bruins. It is evident who got the worst of the hit. Chara is a bigger mass and therefore did not experience a significant change in velocity, whereas Ovechkin did. Thank you for watching this physics analysis of hockey.